Okay, so today I'm going to talk about intermediate Linux. We know that there's all kinds of levels of Linux, and what we call intermediate might be more advanced for somebody who's never done Linux. And we have other classes, lectures for you to take a look at if you need more. The complex program stands for Comprehensive Learning for End Users to Effectively Utilize Cyber Infrastructure. And it's a newly funded program by the NSF, and the training covers what we call non-programming skills. It doesn't mean you're not writing some programming for your application, but you're not writing parallel computing programming, which is a different skill set. But these are more designed to enable you to get onto a supercomputer like Expanse or other systems. And the topics include basic parallel computing concepts, Linux tools, bash scripting, security, batch computing, and how to get help in data management and interactive computing. And we've added a few more topics like parallel Python. We'll cover that in the fall. So you can go to the complex website and take a look at the different topics. And it is supported by NSF Award 2320934. So with that, we'll go into the introduction. So who's this session designed for? Anyone who works in a Linux environment and they need to acquire additional skills to more effectively use cyber infrastructure. We have a basic introduction to Linux, and then we have an even more basic introduction document, markdown document you can work from. We know that getting onto supercomputers is a challenge. We know that you're getting onto them because you need them. You need to scale your application, and we understand the challenges associated with working in this new environment. And Complex is dedicated to that challenge. So take a look at what we're doing today and take a look at all the other opportunities in the Complex webinar series and watch them. And you can interact with the videos, stop, listen, try things. We have, like I said, the GitHub repositories. If you're at this session, you're probably not a sys administrator. Rather, you're more likely a newbie, a student, a developer. But for you, what beauty is in the eye of the beholder, we like to say, and what we call, intermediate Linux for a sys administrator, that's like basic. But for us in the environment you're learning to work in, it's a little more advanced than even introductory Linux. So we've taken some of the materials and split them. Shell scripting has been split out into a separate session, and you can see a complex webinar that we've already recorded for that. So we appreciate that the level is depending on the challenges and experience and background you've got. So prerequisites, we assume you can do some Linux basics, and if not, we've got links to Linux basic tutorials, like I've said. We've got your back covered in that area, but you should be able to list files, remove files, navigate through directories using the CD command, to list file contents using the cat, head, tail, less, and more commands, and the ability to use one or more standard editors like VIM, VI, Emacs, and Nano. And then that you understand relative and absolute paths. It's very similar to Windows, but we use a different backslash and a forward slash instead of a backslash in Windows. Some of the commands are even the same, but they do different things. All right, so let's start with linking, symbolic links. Each of the topics in this talk, and some of them go very quickly, they're just topics that we know are important. And the soft links are a way for you to refer to a file by a different name. For example, you have a basic file that is located in a reference directory, but you're going to use it in different applications. So you do a soft link to that file, and then you can always have that file available. And importantly, if you make changes to what we call, the file one, the main file, it'll show up and be usable in your development directory. So to create a symbolic link, you use the ln command with the -s option. Without -s, you'll make a hard link, and we talk about that in the supplementary material. And we'll show how to use these in the next couple of slides. So the file one is the file you want, and soft file one is the soft link. So here's some examples, and again, you can get all these examples in the GitHub repository. So here we're going to do an LS, which is a file listing, and it shows that there's file one. And then we'll do a soft link to file one and call it file one soft, and do a soft link to this existing file. And then -s file two to file two soft. Right now we're doing that with a non-existent file, just to be able to show you that you can, but also what happens when you're linking to a non-existent file. So file one has some contents in it, and file one -soft has the same contents. So cat is the concatenate command, but you can use that to print out the contents of a file. So here's file one, it existed, it had contents in it, and both the hard link and the soft link and show the same contents. That tells you the link command here worked. But for file two soft, there is no such file or directory. So, but here we're going to use a tricky little command, which is echo, and in quotes I write contents of file two, close quote, and I redirect. That right arrow key is the redirection key, and I put it into a file called file two. So contents of file two, and if I cat out file two soft, contents of file two, it prints out the contents that we just put into it. So there's quite a few commands in here we're assuming you know, and then the soft link concept here. Now this soft link works. So we're going to LS, we're going to look and see that we have file one and file two, file one soft, file two soft. And now I'm going to remove my soft links, but I didn't remove the original files. So the files persist even when you get rid of the soft link. Okay, so you can have multiple symbolic links. So here we're showing you how to make file soft one, soft two, and soft three, pointing to file one. And then they all show up as files in the directory. Okay, so symbolic links can also point to a directory or files in other directories, but you want to use the absolute or relative paths, and they can even span file systems. So here we are in Bob Sinkovic's home directory, and we do a directory listing. We make a soft link in this directory to a file in Expanse, Lister, Scratch, Sinkovit, file 4, and we call it file 4 soft. And when I cat file 4 soft, I see the contents of file 4. So this becomes really useful when you're doing a lot of debugging and running big jobs, and you need to be able to look at results, for example.
Mary?
Okay, so yes.
There's a question in chat.
Okay.
Is the symbolic name relative to the working directory, or can it be accessed with the name regardless of current wording directory?
Current working directory.
Wording.
If that symbolic file name is in that current working directory where it exists, then it would find that file. But if you move into another directory where you don't have that soft file that you just made, it won't be findable. You can use the full path to the directory where you made that soft file. So it has to exist where you are. Okay.
And then there's one more.
Okay. What do you mean? What do you mean by soft link? Soft link is just what I mean. If I do a listing and I've got the contents are actually in file one, that's a physical file that's in the iTable, and it's part of the hardware contents and stored somewhere physically on the computer. But file one soft is a symbolic or a virtual link to that file. And it allows me to go into a different directory, make a virtual link to that file, and then have it be available in the other directory that I'm working in. Okay, great. So how do I know if a file is a symbolic link? You can use ls-f, puts an at a symbolic link that shows here that these are soft links. They're symbolic file links. The actual file is this one. Now, if you deleted file one, that soft link wouldn't point to anything anymore, and you'd get an error. And then you can use color to also auto display, but it adds overhead to file system operations, and it depends on whether you really need and like color. I find color annoying. I'm just all one color, like, one color for all the fonts. But some people like that, but also sometimes you'll be logged on to Expanse and there'll be hundreds of users on there moving files, doing some work like compiling and debugging, well, mainly compiling. And you'll do an LS and it will take a minute to show up. It can take a long time because so many people are doing so much work. So be careful when you use it because it might slow down your work. All right, so let's get in here. Next slide. So the usage scenarios for symbolic links tend to be an application we use that has multiple versions, and we might need access to the earlier versions, but we normally want to work with the latest release. And so by creating a symbolic link to this most recent version, you can avoid having to update job scripts or workflows by you just update the link and you've got the right file. So an application might take multiple input files, and while one of these files is different for each calculation, others refer to some reference data that rarely changes. So you can create symbolic links that point to those reference files, and then new scripts can just keep pointing to the right file. And then here's a usage scenario. I'm going to go into $home, remember, is the location of your home directory, to some file application bin, and I do a listing. And I see that there's an executable, CDF app v1, CDF app v2, CDF app v3. And I do a soft link of CFD, sorry, dyslexic reading there, CFD app v1.3.exe to CFD app.exe. And now that's always going to point to v1.3. And then I go to reference data and I have all these different reference files and I create a soft link to this file and I call it reference dat. Then I set some environment variables for my path to know about $home application bin. I was up here in application bin and reference path to be $home, that's my home directory, application reference data, that's this directory, and cdfapp.exe immediately gets found because it's in the path. And this is basic Unix. And if you don't understand this, go back to one of our introductory Linux webinars. And so now I can find reference stat and I can pass additional arguments as needed. So I can use the symbolic links in a JavaScript to automatically use my latest versions. And so you have to also understand what the path means and creating these virtual links to these paths. All right. So now we're going to do a fun one, which I really use. I find I use this all the time, redirections and pipes. So most Linux commands write to standard out. There's three places: standard error, standard out, and standard in. When I type into a terminal, that's called standard input. And when I write to the output, it's standard output. It's usually the terminal unless you tell it to put it somewhere else. And that's called redirection. And you can use it on the command line. You can use it in shell scripts. You can use it in batch scripts. And these are Unix commands that are universally recognized. So the redirection symbol says date. Here we show an example. The redirection will take the output from one executable or one command and direct it somewhere else. So for example, I say the date and I redirect it to a file called out file, and I list out the contents and it shows me the date. That's a really simple example. And I'm going to put the new date. I'm going to show the same two steps, though, in one step. I run the Unix command to get the date and redirect that into out file, and I get an update to it. So it overwrote the contents of the file. But if you want to save what's in that file, you do double arrows and it will concatenate and add new information to the bottom of the file. This is really handy when you're searching for information. You want to just build up a bunch of greps that you found some data from different files and you want to put it into one big long information file. Redirections and pipes. So the pipe takes the standard out from one command and redirects us to the standard in of a second command. An arbitrary number of commands can be connected using pipes. So here we want to count the number of files in the current directory. We do an ls-1, pipe it into word count -l, ls-l, and we get 13. And what we're looking in is the number of files that are in a current directory. And then we count the number of files. Here, we can list the 3 longest running jobs on Expanse, another example. SQ is the command on Expanse that tells you about the jobs. I look for a particular node where jobs are running. And in this case, I look at just the 3 top entries, and I find that I have 3 jobs running, and they've been running for different amounts of time. A little caveat on that, when you run this looking in SQ, depending on how many jobs are running on that node or on any node, the output may shift a little bit, but you can at least, the purpose of this example is to show how the pipe command works. So here's a redirection and a pipe example. So you can use redirection of the standard input where you're writing and typing into the terminal. This is sometimes useful if you want to prevent a command from listing the name of the input file. In the example below, we pipe the output from word count into the cut utility. So word count -l file 1 shows you that there's 9 words in file1.txt. And that includes the file, and the output includes the file name. So word count -l file1.txt, now we're going to pipe that into cut-d with brackets, with apostrophes, -f1. And we find that just the line count is 1, and we get 9 lines in that file, excuse me. So then we can also just redirect file 1 into word count -l. And in this case, we count 9 lines. Wildcards and globbing. So wildcards let you express a pattern for matching multiple file names using any combination of the following. Question mark will match any single character. Star matches any string, including empty string. Left bracket, right bracket with some text in the middle of the ... stands for any text. It'll match multiple characters or ranges. This is really useful when you have a lot of output files, for example, and you want to find the ones that have a particular output file name. And so then you could use one of these. Or if you just want to look in your own directory and you're looking for particular file names. And then globbing is an operation that expands the pattern into a list of files. It's done automatically by a lot of Linux utilities that operate on files such as ls, remove, move, cat, head, tail, and file. I see we have a couple of questions here. What if I edit the soft file? No, it won't change the original file. Can you copy, or I don't think it does. Can you copy or move the link? Oh, wait, I answered that one. Okay, thanks, Cindy. Yeah, if we don't have anybody helping out and answering real time, we'll come back to all of these if I miss them. Wildcards and globbing using the star. So star stands for any string, including an empty string. So here I have about 20 files, some ending in .txt, some in .dat, some in .exe, and I'm going to ls file star. So list any file name that begins with file. And so axcde won't be found, but all of the files here, notice these are in alphabetical order. It should list all of these files, but not fx. And indeed, that's what we get. List any file beginning with an F. Now we've brought in some other files. And you can use it for the ending as well. File star dot star, for example. You can list file names containing the string GHI, and that finds 3. So you can play around a lot in finding the kind of file that you need and that you're looking for. Let's see. Yeah, now here we're working with the question mark, which is 1 character. So now we just want to find files that have 1 character between file and the dot. And so it does find these files. And then I'm looking for LSA question mark CDE dot star. Now I'm using 2 of the wildcards and I'm globbing them together. So I'm looking for A plus any single character plus CVE dot, and then any string. So it could be a DAT or an executable. And that gives me abcde.text and axcde.exe. And then here I'm doing ls, and I have 1, 2, 3, 4, 5 question marks and a question mark dot x. Any 5 characters plus a dot plus any character plus x plus any character. And we get a very interesting collection of files. So these are probably 2 of the things you're going to use the most when you're looking at file information. Like you're running a bunch of jobs, you have a directory, it's got 75 output files, and you want to find the ones that ran under certain test conditions, and you're naming your files with test conditions in the names. That's the scenario I do a lot of. I try to name my files when I'm running jobs so that they have some meaning to the job that I ran, like the date, variables that are key variables I'm changing. It's kind of like a mini lab book. The names of the files can be very long. They can be, I think, over 100 characters, at least 80, but maybe longer on Expanse. So you can get real detailed. And I learned about this working with a bunch of astronomers. Their file names were like 150, and they just went on, but they said, no, this is how we sort them when we run our jobs. So I'll sharing that little. Okay, so now working with the brackets and a string of characters inside. So here we have the same files, and we're going to do an ls file 1, 3, 1, 1 and 3 dot dat. So multiple matching using a list of characters. So we got file 1 and file 3, and that's different than 1-3. This is going to be interpreted by the Unix system as 1, 2, and 3. So notice it now found file 2. So you're doing a range. You could do F through G, could do that, or F, H, M. It works with numbers and letters as well. LSAC, X star dot star. So any file beginning with A or C that has X followed by X and then anything after the X and any extension. And that found AXCD and CXEF. So now we're going to do LSA A through C, and it found A, B, and C. So multiple matches using a range of letters. So you can see that you can do a lot with this. So aliases, what time does it make sure? Got to speed up a little bit, I think. So aliases are ways of kind of like the soft links. They're shortcuts for Linux commands. I use them all day long. Like on my laptop, I have an alias for logging onto Expanse. But the term the way it works is you use the command alias, remove equals single tick rm-i single tick. And that is and if you do which remove, which will find that command for you. That's a very useful command. Alias, remove, it shows you what it is. And it shows you that there's the command name is user bin remove is this command right there. And this is one that we like to show because especially early on, it's real easy to wipe out an entire directory by accidentally typing remove star. It'll remove everything. But if you've aliased it, then the -i, the remove command will say, are you sure you want to delete every file in all of your directories? So you might consider aliasing this command. And you can abbreviate really long commands as well. Like here are 2 that help you look at partitions on your info, the S info, which is run on the jobs running on Expanse. And this is sinfo-out with a string of line data formatting commands. Excuse me. And so there's the alias for partitions. But this would be a fun one for you to try out and see how much information it gives you about the jobs running on Expanse. Aliases can be listed by running alias without the arguments. So in this case, there's quite a few aliases here, and they all do interesting things. One thing I do is I put the aliases into a bash file, and they get built out automatically for me, and we'll show you how to do that during this talk. So command history, you want to know things that you've done, like, oh man, what was that command that worked when I was doing a particular compilation or running a job? So if you type history, the snip in here, history can be 500 lines long. It depends on your bash environment, your script, your run job environment. But this one shows you which command and what it was. So then to run that command, you can use the bang symbol, and it'll find the last command you ran with ls, this one here, and you see it, and then you get the output. So it's so powerful to remember to use that you don't have to retype everything. You've got this bang command. And then execute the last command is bang bang, and it will run for you. That's that here will, whatever was the last command. 430 was hello, and so it's echoing hello. And you can, like I said, execute a specific command by putting that number in there. All right, navigating between directories with push D and pop D. This one gets a little, it's a bit of a challenge to first wrap your head around it. But if you think about push D and pop D as operating on a vertical, a column of data, and in that column of data are the directories you are in, were in, want to be in. And so I'm in directory 1, and this example, by the way, is in the GitHub repository. I'm in directory 1, and I do a push D, so I put the directory into that vertical matrix, that vertical column of data, and it also remembers where I am. Then I push D /dir2, so I go up one level and into the second directory. And now it shows me my 3 directories that are stored. And I push D into directory 1, and I push myself into that directory. Then I push up 2 directories. This is where it gets a little, where am I in that stack? And I'm going to be going into one of these, this directory, I believe. So you can look at all the directories that are in the stack. And if I do pop D, I'm going to go to the first one, and that's directory 1, and I should be in directory 1. And pop D +1, I go into my main directory. So here's a concrete example. And again, you have to draw it out and work on it several times. I always found it challenging. The person who wrote this understands it much better than I, but you play with it, you'll get it if you need to be doing this, if you need to track the directories that you're in. So while developing an application, we want to alternate between modifying and testing the code. To keep our work organized, code development and execution are done in separate directories. Using push D and pop D allows us to easily move between the two. So we're going to go into the code directory, do some tasks, edit the code, build an executable, compile it, run it. But then we go into the run directory. We put that into the stack, and then we're in the run directory. We run the code and examine the output. Obviously, when you edit and build the executable, it puts a copy of the code into that directory. And what are the directories that I'm aware of? My render, my code dir. It confirms that the 2 directories are in the stack. I'm going to do a push D, and I'm going to go from the run directory to the code directory. And then I'll edit some code, I'll do a push D and go to the run directory, run my code and examine the output. I find sometimes, to be honest, sometimes you can master this. I always just end up opening multiple terminal windows, and one is my compile window, one is my edit window, and one is my run window. That's just how I develop the system. But there's lots of ways, and learning push D and pop D is worth it. Okay, so environment variables. Good, we're about on time. Knowing in Bash and Unix, there's the shell and the environment variables associated with it. That earlier I showed you the command where we use the value $home. That's an environment variable. So the different shells handle environment variables similarly. There's Bash and C shell and T shell. Most of our examples are Bash. These allow you to customize your environment and control how, like aliasing is really setting up an environment of aliased commands. So these shell variables are known in the current shell. Environment variables are known globally and are inherited by processes and shells that are launched by the current shell. It's important to know the context of which variables and environment variables are available depends on what you're doing. So in the current shell, you have what's called the shell variables. And then environment variables, you'll make and set them, and they'll be exported to all the different shells. And you'll generally want to use environment variables rather than shell. We'll show you some examples. The shell variables are set using the key equals value. It can have multiple values, syntax. The space is not allowed around that equal sign. And by convention, the key is capitalized. So key could be name and equals Thomas, right? Mary Thomas. So NAME would be capitalized. Thomas might be uppercase T, lowercase HOMAS. And the variables are made into the variable into environment variables. Shell variables are converted to environment variables using the export command. And we'll show you an example. So what's a simple example of working between shells? When you log on and you're compiling and setting up to run a job that would run on the cluster using batch scripting, we'll talk about that in another webinar. You have variables that are in the shell environment, but if you need to define particular paths to your data, particular values for certain things used in your application, you would just find those in the shell and export them to be an environment variable, and then when you submit your job, it can be inherited. Okay, so that's an example of where you start a new job, and here we'll show a simple example. But when you start a job that launches you into a new bash shell, these environment variables need to travel with you. You need to set them to do that. So here we define key 1, key 2 having 2 values, A, B, C, D, E, F, G, H. And then we're going to set them, we're going to export key 2, and we're going to export key 3 equals IJK in quotes. So notice we just simplified this part, but there's different ways to export. So echo key 1, A, B, C, D, echo key 2, echo key 3. So we're in the shell where we created all these variables and exported a couple more of them. And now we're going to type /bin/bash. That will launch you into a new shell. And key 1 was only known in the parent shell, so it didn't print out. But both key 2 and key 3 were set to export, and indeed, they exported with that bash shell. Now, if you go into a shell that calls a shell that calls a shell, you have to keep exporting those variables. Okay, so shell and environment variables can be set with the declare command using the -x flag to export and -r to make the variable read-only within the current shell. So here we have a variable ABC, and we declared -x var2 equals DEF. So var1 is ABC, var2 is DEF. And now we'll go we'll go into a new shell, echo var1, value is not known by the child shell, but DEF, the value is exported to the child shell. So we're also using another way of declaring some variable that is exported. Okay, so shell and environment variables can be displayed using the env command. And if you're trying to do a really complicated job submission process, sometimes you need to print out the environment on the remote node that your job is supposed to run on, as well as on the node, on the login node where you're trying to submit the job. This, by the way, can be very, very long, but it should have everything, including your username, the shell, your home directory, and other variables that you're defining in your bash shell and your batch profile. Now, those you would know about that more if you're in basic Linux. So you should go back and learn that if you don't understand what I'm talking about. All right, configuration files. Well, I'm leading myself right into this. So this is covered basically in any talk on Linux, but we want to go back into it to make sure you're really clear on what these files do. And these are for customizing your environment, and they're system-wide variable environment configuration files, and then ones that we would have locally. So there's a hierarchy of scripts and how they execute. And on the next slide is a really great picture that I sometimes just keep it out when I'm doing a lot of development. Like what got executed first and how do I make changes to what got executed? And some scripts can execute source scripts, some only apply to the login shell, but you can get by pretty much with customizing your environments in the .bash profile and put aliases and functions in the .bash RC. And if you're in a different shell like TCSH, it would be called TCSH. All right, so let's see if we can get some more information on that. Then we'll look at how things launch. So the interactive shell is one that reads from and writes to your terminal. If you can enter commands at the command line and see output, you're in an interactive shell. Interactive login shell is launched by using the SSH command and you log on to the remote machine, or when a new shell is launched with the -- login option. This is where you usually work. And a login shell is launched differently than just typing /bin/bash. So that's why we emphasize, is it a login shell or not? Things get done when you log in that don't need to be done or shouldn't be done if you're launching a particular bash shell for a particular application. And figuring that out is sometimes part of testing and debugging your code in my experience. Then there's the interactive non-login shell. It's launched from a login shell by executing bash at the command line or opening a new terminal from the Linux desktop, or even submitting a job to the Slurm batch management system. The batch system is how we run jobs on a system like Expanse, and it's how you get your work to run on the multiple HPC nodes. So understanding which shell you're in is very important to know which environment variables are being inherited and what you can do. Okay, so non-interactive shell is not associated with the terminal, usually launched by a user executing a script or some automated process. And so here's the order of execution. The orange is the system, the blue is the user. And depending on what Linux you're working with, these might have a different name. But in general, there's, for the user, for the system, etc profile is a folder where they have etc profile.d and etc bash rc. You can look in them and see what's in them. You can't change them every time you run any job or you open up a shell or a terminal. Those will get run for you, and they do everything that they're supposed to do for the interactive. And then once you're logged in, the .bash profile, the tilde, remember, stands for your home directory. That loads in all the stuff that you put into your .profile, and then the .bash rc is sourced after that. And the .bash rc is important because it's what's used in an interactive non-login shell. So you can put whatever you want into both of these, but if you have a particular aliased command or a particular path you need to a particular library that you need to see it when you're on a non-login shell, then you want to make sure it's in the .bash rc. So take this picture, put it somewhere where you can get at it often, especially when you're first developing. It's pretty handy. And the source for this information is here. All right, so if you do internet searches for Linux configuration files, you'll probably come across figures that look like this. But the good news, that look like this. There's something missing on this slide. But the good news is if you're using Bash and you're not a sysadmin, you probably just need the two files. Okay, so that gets simple. Just always put all your important stuff in these two, and then you'll be fine. All right, configuration files. The .bash profile configuration files is only run once, such as customizing environment variables in the local path that you want to use within this shell. It's usually your .bash profile by default, and it sources your .bash rc. Notice I'm in here, and it sources my .bash rc. Okay, so this gets called by the system, and then you can further refine the environment that you want to work in. In the .bash rc, we source the global bash file, And then this is where it's convenient to put aliases or to configure your modules for general use or a particular application. All right, pseudo file systems. Oh, we're doing good on time here. Plenty of time for questions and answers. Following the philosophy of everything is a file, Linux provides these pseudo file systems that allow you to access dynamically generated content using some tools that you use to access regular files. They're normally found in /proc and /sys directories. As a regular user, you'll normally use these just to get hardware information. So if you go into /proc, there are two files in here, CPU info and version, and they show as being empty. But if you cat out the outputs, you'll get information. It's very long, but you might need to know what CPU am I using, and some heterogeneous systems might have different versions of the CPUs, and you might have written your code to just a particular CPU version made 2 years ago on a system like Expanse, and you need to make sure you're using the right CPU. So there's scenarios where you'll need to know what kind of CPU are you on, or what version of CPUs am I on, what library then can I use from the Intel compiler or from other bigger libraries like the net lives that are used for parallel computing. Okay, so anyway, there's two of these actually have some data in there. And here's examples of the information that you can get. What's your architecture? x86_64, 32-bit, has 128 CPUs. This might be the most informative. How many CPUs are available? How many are up and running? All of them. How many threads per core can you do? How many cores per socket? Just all this, the name of it, AMD EPYC 7742, obviously this is Expanse. The frequency, and that's important to know for certain applications. Just all that information, and then this is proc CPU info, and all the flags that are available on it. So then for CPU information, LSCPU gives you more detailed information just about the CPU. So this output shows we're on the x86 with 264 core AMD EPYC processors. So we have 128 cores available. And that's just the one node, right? And the CPUs are organized into 8 NUMA nodes, which you might think, why would I want to know that? Well, some applications move data around and share local memory in really complex ways. So learning about the organization of the different nodes is important. And then we might need to know the L1, L2, and L3 data cache sizes. You can interrogate and organize the results for you. So I'll flip on that. Okay, so getting memory information from /proc mem info. So knowing the memory is really important. If you have a big application and you're starting to crash, it's not working right, and you're profiling it somehow and looking at the memory, and you've picked a node that doesn't have enough memory because you're trying to get the fastest and reduce bandwidth, maybe to reduce message passing, you need to know the memory on that node. And that's a scenario where running a command like that will help you figure out, on this particular actual node that I got assigned to by the system, what's the memory? So you might be running these in your bash script file to figure out exactly what's the profile of my node. And you might realize, oh, I need more nodes because I'm using up the memory. My job's too big. It will help you debug different kinds of situations. And so it tells you, you can have it running, maybe run this in the middle of your program and figure out what's happening while you're in runtime. So anyway, there's details on the large memory node and the GPU nodes. So you might run one of these actually inside your app using the system call, and then don't forget to turn that off, because it would cause you perhaps some time to get that information. But these are ways of figuring out where you're running. And Linux quotes, no, this is not quoting, Mark Twain and a good walk, golf is a good walk spoiled. These are actually using quotes. So They're really important. Single quotes preserve the literal value inside the quotes. Double quotes recognize the special meanings of other characters like the $sign, the single quote, and the backslash, and the bang if you're doing history expansion or something like that. So here we're going to have a variable called ABC, var1, var2 is DEF, and I'm going to concatenate these together. Echo var1 plus var2, but it's going to be between quotes, and so I get back $var1, $var2. Usually when you use the $sign, you get back the value of that variable, but I have it between the literal quotes, and so that's what I got. But if I put the double quotes on here, I get the values along the plus sign. So this is useful when you're doing print debugging or you need to print information to save data for a particular application. And figuring out, are you looking at the value of the quote or the name of the variable, and other things you're trying to do is important. If your strings don't require any special characters, you can use the single and double quotes interchangeably. It's handy if you have quotes that you want to quote, like something somebody said, or you're actually building a command that you're going to use later on, but that gets a little more advanced. So you can use the backslash to escape characters too, so that they don't have their special meaning. So here's good morning, Bob, and we've got double quotes and then single quote Bob. But since we're not doing anything with it, the single quotes come out and we see good morning, single quote Bob. And we're going to echo single quote good morning, double quote Bob, single quote. But the double quotes aren't doing anything inside the single quote, so it comes through. Then we're going to echo good morning, backslash single quote Bob, backslash single quote, double quote, excuse me, and we put them in between double quotes, and now we see the double quote Bob. And here's a little bit more complicated. Echo $var1, and we're in double quotes, so that means we're not doing it literally. So here we get the value of var1 plus some other term that starts with a backslash, and Unix works from the inside out. So we're not going to get the value, and then we're going to ignore the one of the backslashes, and we end up with backslash $var2 backslash. I think I got that right, but you can play around with white. Like I said, the reason you would want to keep these in is if you're using Unix to build a complicated command and then run that command. This is one way to start doing that. And I showed you earlier a long command where they printed out the information for that sinfo command. It's using some of this capability. Okay, so Linux quotes and backticks. They're distinct from the single or double quotes and capture the output of a command. I use this all day long. Me equals backslash who am I, backslash date equals backslash date. The backslash means execute what's in between these two backslashes. And on a workstation, it's usually not where you have the double quotes and the single tick, but for me on my laptop, it's in the upper left hand next to the number 1, and it's got a back tick on it. It's a special command. And so I don't know where it is on your laptop, but echo $me, who am I? I am Syncovitz, and here's all the information that you get logged in from that: domain number, domain name, IP address, and the date. So the who am I gives a lot of information, and echo $date gives the full date command output. So it's a way for you to save data. You can use these to get the date, and you can save it. To get information and save it and then use it in a script or something. All right, that's towards the end. That's the summary. If you can learn these skills from our examples, we know it'll help you become more effective and have a happier time playing around on Expanse. It gives you, these are chosen to give you ways to control your output, to investigate what you have, where your files are, to facilitate compiling and running jobs, to capture environment information and use it in your applications and your scripts. And when you run jobs on a system like Expanse, and let us know, how things work for you. Give us some feedback. And also, if you think of a command that you think would be helpful in here, let us know. With that, I'm going to conclude. There's supplementary material for you to go look through on your own to learn and take more questions if you guys have them. But thank you for your time and attention. I really appreciate it.